In July 2005, Britain held its breath for an announcement. London had bid to host the Olympic Games. If successful, it had sparked the UK's biggest and most audacious construction project.
The Games of the 30th Olympiad in 2012 are awarded to the city of London.
The crowd celebrated. Britain now had to host the greatest sporting spectacle on Earth. And that wasn't all. London had swayed the International Olympic Committee's decision with a radical proposal to hold the world's first sustainable Olympic Games, leaving a legacy far beyond the departure of the Olympic torch. This would involve epic-scale urban transformation, the creation of a vast parkland featuring world-class stadiums, a gigantic construction project that wouldn't damage the environment, but enhance it. What's more, to do it all in just 4 years would call for a rewrite of the construction rulebook. In Canary Wharf, the planning of London 2012's Green Olympic dreams began. The Olympic Delivery Authority had a budget of £8 billion, and Chief Executive David Higgins was responsible for spending it.
This is something tangible. This is real, it's jobs, something will be left behind. It's a fantastic showcase for British engineering, design, planning, and construction and supplies.
The foundation stone to London's sustainable plans was the creation of a groundbreaking Olympic Park. Covering an area of 2.5 square kilometres, it'd be the largest British park to be developed in more than a century. Home to world-class sporting facilities for Olympic and public use, with rich and diverse habitats to boost London's wildlife.
We ensured that all of the main part of our money went into the permanent infrastructure. 75p in the pound of every single pound that's spent on this site will be here long term.
Two miles north of Canary Wharf, a site had been chosen for the Olympic Park in Stratford, East London. As one of the poorest and most deprived areas of the capital, it posed a major challenge.
It was rough. A lot of derelict land, a lot of contaminated waste, and had the detritus of industrial development, power lines, old pipes.
The tremendous task of turning this semi-derelict wasteland into prime Olympic real estate was taken on by Jan Hellings.
So we can close it.
We were the very first people on the site, so the whole of the project really was dependent on us.
Without a moment to lose, the biggest demolition project in Europe got underway. The scale of the job was phenomenal. The site stretched to the horizon. More than 220 buildings had to be removed. Thousands of tons of concrete and bricks had to be cleared. But if the enormity of the task wasn't a big enough challenge, Jan also had to demolish in a sustainable way, saving 90% of the materials for later reuse on the site.
It would have been much easier just to knock things down and throw them in the back of a truck and then send them off somewhere else.
Instead of ending up in landfill, building after building had to be taken down piece by piece.
All the buildings, for example, are being crushed, are being used as foundations for other projects. And so the whole legacy, really, of the past lives on in the future.
Scores of excavators demolished and sorted the materials. But the derelict buildings weren't the only obstacles on site. More than 50 electricity pylons and kilometers of high-voltage cables crisscrossed the area.
I can remember coming to the site in 2003 and said it will never work with these huge, massive distribution pylons, 52 pylons, running through the middle of the site.
To liberate the land, the power lines had to be laid beneath the Olympic Park. The solution called for 2 6-kilometre-long tunnels. It was the biggest tunnelling operation in Europe. Its scale and complexity would normally have called for a 4-year programme. But this team had just 2. After months of working around the clock, the first of the underground teams finally broke into the daylight. But hidden in the soil lay a problem that couldn't be ignored. The land was severely contaminated. From the mid-19th century, Stratford was one of London's industrial powerhouses. Its factories supplied a nation and empire with manufactured goods. The world's first plastic was produced locally. But these processes produced highly toxic chemicals, and the pollutants were dumped, leaching deep into the ground, fouling the rivers and the groundwater. With London 2012's promise of urban regeneration, the soil beneath the Olympic Park had to be cleansed of its polluted past. Civil engineer Safina Sharif faced this enormous challenge.
We had fertiliser factories, chemical works, even an old landfill site. So there were a variety of different contaminants within the ground. Now, it would have been very easy to have just dug up the material and sent it to landfill, but in the times that we live in now, that's just not acceptable. London 2012 set a really ambitious target of 80% reuse of earthworks. So looking at how we could best reuse the material was our challenge.
Two 2 million tons of earth had to be decontaminated. It would be the largest soil cleanup ever attempted in Britain.
I'm actually a Londoner myself, so it's quite close to my heart, this project. The work that we're doing here isn't just for the games.
Gigantic soil washing machines eradicated the contamination. Almost every polluted grain had to be cleaned. Claire Staveley was in charge of operations.
The site, because of its past uses, has various contaminants in it, such as heavy metals, arsenic and lead, mercury, zinc and copper. There's also hydrocarbons from oil tank leaks. You're trying to stop this entering into the human and the animal and the plant life.
To stand any chance of cleaning all the soil in time, the team had to keep an incredible pace.
We start work at 7 o'clock in the morning every day, and we finish work at 7 o'clock every night. We work Mondays, Tuesday, Wednesday, Thursday, Friday, Saturday and Sunday.
The soil washers took in dirty soil. The sand and gravel were separated by size and rinsed to extract the pollutants. Huge electromagnets stripped out scrap metal. The soil underwent rigorous testing in a laboratory to assess its health. For the team, awaiting the results was often an anxious time.
You have to wait and see what the results are like. Pester the labs a lot to get turnarounds on that, but it's very exciting when it comes through and it actually is clean enough to be used at a point where you could literally stick your hand in and have a little kid swallow it and it wouldn't be a problem.
Instead of millions of tons, only a fraction of contaminated soil had to be sent to landfill. And mounds of clean earth could be transported for use on site. Some may have thought attempting to reuse 80% of the soil was impossible. But for Safina, reaching 85% reuse had made it all worthwhile.
We've actually managed to do better than has been done before. So we've set the bar and shown all projects, actually this can be achieved.
By September 2007, 90% of the buildings had been demolished. But with the opening ceremony now less than 4 years away, London, along with the world's press, eagerly awaited the design of the first sports venue to be built, the Olympic Stadium. The park needed an 80,000-seat venue, but it had to avoid a common problem. After the Olympic crowds had dispersed, nobody wanted an oversized arena. So London 2012 set architect Rod Sheard an astonishing brief. Ignore the rules of stadium architecture entirely. Embrace the temporary.
All the great architectural monuments of the world are all been there for hundreds of years, and it was a principle of forgetting all of those long-standing icons. A brief that was so fundamentally different to anything an architect had attempted before.
The brief called for a sole-use athletics venue, but its design had to be driven by its life after the Games.
Problem is, of course, track and field doesn't attract 80,000 spectators, but it can maintain a 25,000-seat stadium.
Rod and his team had to develop a flexible venue. And after months of brainstorming, they hit on a radical solution. Below ground, a permanent concrete bowl would contain a crowd of 25,000. Whilst above, a lightweight steel ring would hold 55,000 seats for the Olympic Games. This entire top section could be later dismantled to provide a smaller venue if required.
It took us about 6 months being able to recognise that temporary has a beauty of its own. It's a light building, it touches the earth lightly.
But no sooner had the first design challenge been solved, then another quickly arose. Project manager Ian Crockford discovered wind conditions on site were a problem.
We started to appreciate, actually working on site, you could start to feel the wind. You've opened up a new corridor in London, straight up from the River Thames, and you could feel, literally feel the wind.
The stadium had been designed without a roof to limit steel usage. But an open roof would create turbulent wind conditions on the racetrack that could help or hinder athletes.
Can you imagine building a structure for the Olympic Games and then finding out that the wind speeds in the bowl exceeded any guidelines and no athlete was going to get a world record? I mean, it was absolute no-no.
London 2012 needed a record-breaking stadium. So Ian called upon structural engineer Fergus McCormick to investigate the effects of wind.
We built a computer model of the stadium environment and then had 3 models, one with no roof, one with complete covering over all the seats, and one with a partial covering. We could then set the analyses running with these different situations.
And you'll begin to have completely different sets of...
The results that came through were clear. Without a roof, the wind was sweeping into the stadium bowl and rolling onto the track and field area, creating turbulent vortices.
Track is a little bit shallow.
A partial roof, stretching almost 30 metres over the bowl, forced the wind to flow over the stadium.
They were pretty conclusive. It showed quite clearly that the roof was extremely valuable in controlling and attenuating wind movements down onto the track and field level.
The team quickly got to work on designing a partial roof structure. But with just 6 weeks to the stadium press launch, the engineers began to reconsider their strategy.
There's people working 10 hours a day designing it, and we were confident we were going to launch the press. We had everything set up, and that's when the design team said, you know what, we could do this a little bit differently.
The heavy-duty roof was designed to take the immense structural loads created by wind. But the design was getting too big and using too much steel.
It was then we started looking at the weight of that structure and how you could do it a bit differently, and the idea just clicked that we could do a really sophisticated, lightweight cable net roof right at the last minute.
The cable net design was a masterstroke. Assembled like a bicycle wheel, a lightweight steel frame would support a thin fabric roof. When tensioned, the roof would take the immense loads whilst using a fraction of the original steel required.
Nobody's going to put back the opening date of the Olympics. Every time you come up with a solution that doesn't quite make it, you get just that little bit panicky.